sure it's. Okay, so like I was saying, the proofs here for the triangles, at some point, they really just become easy. All right, all you're doing is using the information. All right, and what I mean is you have to figure out one of 4 ways to prove the triangles are congruent, and those are the 4 ways. Now, again, when you're thinking of this, all right, some kids get confused. All right, so we have a little geometry joke coming your way. All right, so you will probably enjoy this one. You are not allowed to use angle, side, side. That is the one you are not allowed to use. All right, for obvious reasons. All right, if you put that on your paper, we will have trouble. All right, so with that being said, all right, with that being said, these are the only 4 methods. You can write them forwards and backwards. So side, angle, side obviously is the same. Side, side, side is obviously the same. You can use ASA, that is the same as angle, angle, side, and angle, side, angle, written backwards is the same also. All right, so with that, all right, being said, all right, when you draw your triangles, let's just make sure, because some kids, for whatever reason, are not sure exactly what I'm saying. So what I will do is I will just try to show how I know those 2 triangles are congruent if I say an angle and an angle, the included side. That's what that means. The side is between the 2 angles. Now, if you don't pay attention, all right, for whatever reason, I don't know why people don't see that. All right, the side has to be between the 2 angles. Over here, angle, side, angle. Now we know for sure those 2 triangles are congruent because the side is between the 2 angles. All right. Now, that one's a little bit easy. Side, side, side is a little bit easy. Now, side, angle, side, we did last week, would be something like this, where the angle must be between the 2 sides. That's what side, angle, side means. All right. Now, for whatever reason, angle, angle, side is a little bit trickier. All right. But again, I don't understand it, but some kids have trouble. So this right here and this right here would now be an example of angle, angle, side. All right. The 2 angles are congruent, and then the side. Now, if I wrote it like this, would the triangles be congruent? No, they're not. Why is that? Because it goes from 1 tick mark to 1 tick mark to 2 tick marks. All right. This one goes from 1 to 2 to 1. They are different. All right. Does everybody understand what I'm saying? You have to be careful when you mark your figure. Some people think that that's angle, side, angle. Some people look at that and say that's angle, side, angle. It's not angle, side, angle. The side's not between the 2 angles. Does everybody agree with me? All right. You're not reading angle, side, angle. You're skipping an angle and a side. You can't do that. All right. So hopefully that is making sense. So those are 4 methods for which you can prove triangles are congruent. All right. And it doesn't matter. All right. There's lots of different ways. And that's why I tell kids it's sometimes a little bit harder for me to grade your test because I have to figure out what you're doing. All right. So your test now will just be prove this. All right. And you can write everything out. All right. For the most part. All right. So now let's look at question number 6. All right. Obviously it says write a paragraph proof, but we don't write paragraph proofs. We write a 2-column proof. So ignore that. We're just write the proof. All right. So here we go. So let's see what we can do. Again, We can copy this. Oh my goodness, come on. All right, now we can paste it. All right, here we go. Step 1. And then we can just say it's the given. All right. Now what I like to do is, as I'm reading the given, I like to mark the figure. All right. So the first statement says, is that CE bisects angle BED. So I like to find BED and then I like to bisect it. So to do that, we're coming over here. And so somebody tell me what is true. Elise, go ahead. You got to tell me. What?
CD and CD.
No, not from that. Tell me, Nate.
BE is congruent.
No, you guys are way off the mark. Tell him, James.
BC is congruent to CD.
What am I? No, guys, no. Chloe, tell him. No, man, you guys are killing me. I thought I was doing a great job today. Go.
BEC is congruent to BEC.
You mean angle, right?
Yeah.
Yes, that is correct. Guys, come on now. This is what I don't understand. All right, so I need someone to help me. All right, and tell me what you're not seeing. I just said that CE bisects angle BED, and somebody was telling me about sides and other things. CE bisects a what? Angle. So what's true when CE bisects an angle? The angles are congruent, right? The angles are congruent. Now, again, I can't do really any better than that. I'm sorry. There's just no way for me to explain it any differently. Sometimes I can try to explain things a little bit different. But if I tell you that a segment bisects an angle, that means that it cuts the angle in half and it cuts it into two congruent angles. That's what you're getting from that information. Is everybody okay with that now? So as soon as they tell you the segment bisects an angle, it just creates two congruent angles. All right. So I found BED. All right. I found BED and I found CE, and CE bisected that angle. So now, of course, Lexi would tell me that angle BEC is congruent to angle DEC. And of course, we just simply write, that's the definition of bisect. That's the definition of bisect. Now, someone did say something that was true, but it was not the question that I was asking about. All right, who mentioned something about CE? What is that? Yes, CE is definitely congruent to CE. So step 3, CE is congruent to CE. Why is that? That's the reflexive property. I don't think that's that bad. Reflexive property of equality. So now I'm going to mark that twice. Okay. Now it says that ECD and BCE are right angles, right? So what's true?
ECD is congruent to ECD.
Yes, that is true. E angle ECB is congruent to angle ECD. And why is that?
Single side angle.
No. No, I only have an angle and a side. I can't say angle, side, angle. I only have an angle and a side. Tell us.
Right angles are congruent.
All right angles are congruent. I'm not sure what you said there, Will. ECB, you told me ECB is congruent to angle ECD. Those are angles, not triangles,
Oh.
right?
Mhm.
So we can say all right angles are congruent. So now I can come over here and you can mark that is a right angle and that is a right angle. All right, and if you want, you can put 2 tick marks or not necessary, but I'm just showing. Is that okay now?
So we have to prove that the two right angles are equal to each other before we can prove each other.
How else do you want to do it?
So I'm just confused, because they wrote that BCD and ACD are like right angles and they're given, so do we still need to prove that they're equal to each other?
You have to state that they are congruent. Yes, you have to state that they're congruent. Because we're using that angle, side, angle. All right, you have to tell me that an angle, a side, and an angle are congruent. And once you do that, then we know that the triangles are congruent. All right, so now that we've established that, we can now come back and we can grab this. Paste that in. And now, why is that true? Yeah, angle, side, angle. Like I said, I just didn't think that was that hard. By looking at the picture. What do you mean? What did you want it to be?
I don't know, I was just.
You don't know. You're not looking at that figure saying what is congruent to what. Yeah, and again, I'm saying I understand confusion because I think it's obvious and some people don't think it's obvious. So I'm trying to figure out why it's not obvious. Angle, side, angle. What does that mean? An angle is congruent to what? Another angle. And what's S mean? A congruent side is congruent to another side. What does A mean? Exactly. I don't know how to make it any easier than that. This is the angle, this is the side, and this is the angle. Every year somebody asks me, well, why isn't it angle, angle, side? I'm like, how am I supposed to help you? The side is between the two angles. Is this side between those two angles? That's why it's called angle, side, angle. Angle, angle, side. That would be two angles and then a what? Side. All right, side, side, side. All sides are congruent. Is there an angle, angle, angle? No, there isn't. How do we know that's not true? Tell me.
Because what if the angles could be the same, but then the triangle is so much longer?
Yeah, exactly. Think about it. Every equilateral triangle. If that's an equilateral triangle, what are the degrees of that triangle? What are each angle measure is would be what? If it's the same 60 degrees. So if that is an equilateral triangle and that is an equilateral triangle, are they congruent? Are those congruent triangles? Is this triangle here congruent to this triangle here?
Yes.
Who said yes? What does congruent mean?
The same.
Are those the same triangle?
No.
That's what I'm trying to show you. They're not. Do they have the same angle measures? All the angles are 60 degrees. So are the triangles congruent? No. Angle, angle, angle never works. There's only 4 cases that it does work. All right. Now, eventually, when you take pre-calculus, you will learn a lot about angle, side, side. All right, that's called the ambiguous case. It's possible to make 2 triangles out of that. All right, and then they will explain to you exactly how that happens. All right. But for us now, we're just studying just the congruent triangles, just the congruent triangles. All right. Everybody good with that? All right. Marin, are you okay with that being angle, side, angle now?
Yeah.
All right, here we go. Let's try the next proof. Okay, this one's going to be, can we say XZ is congruent to XZ and then the triangles are congruent?
Yeah.
Yeah, no. Side,
Tell me,
what?
why not?
Because that would be side, side, angle, or angle, side, side.
That would be angle, side, side. And like I said, some of you said yes so quickly, and I'm just not sure. I'm not, does everybody understand? Like, I'm not understanding what you're not seeing. This isn't, if I said that, this would be angle, side, side. Is that possible to prove they're congruent with angle, side, side? No, you can't use that. So I always need either, I always have to have at least one side, but then the angle relationship to that side is important. All right, so is everybody happy with that? All right, you definitely, so we can say XZ is congruent to XZ, but that doesn't help us prove. So what we're gonna do now is, please listen, do it on your own. All right, that's what I'm hoping you're doing. If you can do number 7, then you can do the next one and the next one and the next one. All right, I would like to hear honestly from everyone who's having trouble. All right, because I know there is trouble. All right, because every year there is. All right, but I need you to tell me, all right, what you're not seeing. That's what I need to know. All right, so I can try to help you. So here we go. I'm going to put all this down, the given. I like just putting in one step down here. And then the next thing I am trying to remind you is put step one, given, and then use the given and mark the figure. All right. I should have eliminated those marks is what I should have done. All right. Angle W is congruent to angle Y. So I'm just going to go ahead and remark that. And WZ is congruent to YZ. Okay. Now it says that XZ bisects WZY. So again, I'm going to let Elise now. Come on, kiddo, jump on in there and tell me what that means. XZ bisects angle WZY. So first, highlight on your paper WZY, please. It's really simple if you do this. That's what I'm not understanding about some of you. All right, if you want, you have to draw the angle. And then you have to draw the line that bisects that angle. And then to me, it was crystal clear what it means. But if all you do is look at it, it's not helping. So, Elise, tell me what angle am I highlighting? I'm highlighting WZY. Now what? Now what does it say? Right, so I'm now going to highlight XZ. XZ is the bisector. So what does that mean? Shh.
That XZY is equal to XW, no, XZ.
That's how simple that is. That is how simple. If you don't draw and draw, you can't see it. I'm not expecting anybody to look at that and say, oh, that's so obvious. I don't do that. I don't look at that and say, oh, that's just obvious. Right? You have to draw and write and label the shape and the figure. So that is most excellent. So now we come over here and we say this. I'm going to put as 3 tick marks. So tell me again what you just said.
XZY is congruent to XZW.
Yes, thank you. XZY is congruent to XZW. And don't forget, those are angles. All right, now why is that again?
The definition of bisect.
Yay, definition of bisect.
Could you also flip it around and say?
Yes, yes, I don't care about how you label it. right? As long as it's y, z, x, as long as z is in the middle, right? And you can also switch these angles, right? You can turn it around. Okay, you write it. All right. So Elise, why don't you finish off the proof? Come on now.
Okay. Then XZ equals X.
We can say that. Is it necessary to say that?
No.
Tell me the 4 ways you can prove triangles are congruent.
Angle, side, angle.
Angle, side, angle,
Angle, angle, side.
angle, angle, side.
Side, side, side.
Beautiful. And
Side, angle, side.
now what you're doing is you're looking at this figure, Elise, and tell me, is that matched up with any of those? What do we have so far?
Angle, side.
And so I'm agreeing with you. Now I'm going to do this for you. Angle and an angle. What else?
The side.
A side and a side. And what else?
The side.
Nope. Angle, side, side does not work. What else?
And angle.
Yeah. But are you guessing? Or are you telling me? Right, because this angle right here is congruent to this angle right there. So I have an angle, a side, angle, congruent to an angle, side, and an angle.
How do you know that that's an angle?
Very good. All right, now we're learning. All right, so I'm gonna go back here to this piece right here. Start over because that's garbage. All right, you just told me, am I correct, that this is equal to this? Do you agree?
Yeah.
This is already equal to this right here. Do you agree with that?
Yeah.
And this is equal there. Do you see that?
Yeah, but I don't get why there's like angles in that equation.
Okay.
Why would it be XC?
Tell me, I didn't say anything about XC. You're wanting to add XZ.
Yeah.
We don't need XZ though. You can tell me XZ is congruent to XZ, and I'm gonna show you something else now. All right, but I'm trying to get you to realize, is that enough information to prove those triangles are congruent?
Yeah.
Because we can say it is what?
Angle, side.
Yes, we can say it's angle, side, angle. Does everybody agree with that? Now, let's just say for some strange reason, you didn't see that. All right, let's just say that's okay. I didn't see that right off the bat, which is possible. And then you told me that XZ was congruent to XZ. Now, what could you say? Those triangles are congruent by what? You could say they're congruent by side, angle, side. Does everybody see that? You could also say the triangles are congruent by angle, angle, side. Now, if you don't know that, you can raise your hand and just say, slow down a little bit and show me what that means. Or because like I said, I'm sorry, I don't understand not seeing the relationship. All right, now, Elise, are you happy with what I said?
Yeah.
You understand, you could do XZ is congruent to XZ, then almost all possibilities are there. Is everybody agreeing with that? If you said XZ is congruent to XZ, you can now say angle, angle, side, angle, angle, side, angle, angle, side. You could also say side, angle, side. Could I say side, side, side? No, because I don't have what? I don't have the third side. Thank you. I don't have the third side, so I can't use side, side, side. All right, so we just did angle, angle, side. We just established I can't do that. Did we do angle, side, angle? Did we do side, angle, side? So you could virtually prove it, everything except side, side, side. Is everybody okay with that? If you decided to mark X, and some of you are going to do that. Some of you are going to mark XZ is congruent to XZ and go into some other, do I care? No, I just wouldn't have done that. I would have just said, wow, that whole proof is pretty much done for me. Everybody good? All right, let's see if we're getting better. Let's try the next one. Okay, so let's everybody grab the given. All right, come on now. You want to tell me? What are we using? Tell me what to do. Step number 2.
YV is congruent to VW.
YV is congruent to VW. Why is that? Yay, definition of midpoint. She read the first statements. V is the midpoint. Midpoint is like bisect. All right. So I want everybody to write down YV is congruent to VW. And that is definition of midpoint. Thank you very much. All righty. You want to just do the proof? Thank you. All right. So what in the world are they telling us about parallel?
That WX are parallel, so wouldn't that make angle VWX congruent to
VWX, brilliant. VWX is congruent to what?
VYU.
Yes, very nice, very nice. All right, now, of course, that's hard to see. So what I teach kids is, let's go ahead and just draw this down this way. Not necessary for some, all right? But if you're having a little bit of issue, just draw this here, and then draw this way. And now you should be able to see what type of angles are those?
Alternate interior.
Yay, alternate interior angles. Does everybody agree with that? All right, so now I'm going to come down here and you can tell me again. What did you say?
VWX is congruent to
Angle.
angle.
VWX is congruent to angle VW.
Sorry.
Is it U?
VYU.
VYU. All right, I know the alphabet is a tough one.
Oh.
VYU. And we would say, what are those? Alternate interior angles are congruent. All right, so I'm pretty happy with you. All right, so now what? Come on, finish this off. And you will be a superstar.
Oh, this is. Oh, Marin.
No,
Oh,
you are doing it. What else? Don't make Lexi jump in here.
Lexi can help me.
Lexi, tell her.
Couldn't you do vertical?
Vertical angles. Exactly. What are those vertical angles?
UV, and WVX.
This angle right here. Exactly. Is congruent to that angle right there.
Oh, that was stupid.
That was easy. All right.
Thank you, Lexi.
So we can say from there, we can say that angle UVY is congruent to WVX. And of course, that is the vertical angle theorem. All right, Marin, what else were you going to say?
Nothing.
Tell us.
You could do the alternate interior.
Yeah, you could do the other alternate. That's why I'm trying to tell you guys. That's why I'm saying it's not just one method. He's saying, look, we could have also proven that this angle is congruent to this angle. And now you have what? Angle, angle, side, right? This method is what? How do we know the triangles are congruent now? Angle, side, angle. That is correct. So now we need to come over here. Step number 5. What did you say it was? Angle side angle. Of course, if you're like Lucas and did the other alternate interior angle, which would be true, all right, then you wouldn't say angle side angle, you would say angle side. Yes, sir.
I didn't do that one, I just realized it.
No, I'm just saying, you said it though. That's why I'm giving you credit for it. All right, you don't have to prove it that way. All right, I'm just simply saying, if you forgot vertical angle theorem, which obviously some people will, right? Kate Mitchell?
I'm sorry, Mr. Shaw. Hey, I did good until.
Yes, you did good. All right. Anybody have any issues with that? Come on, that's not hard. All right, let's go to the next one. I don't want to see something else. Let's go to number 12. You can do the other one for homework. All right, so I'm going to do number 12, and then you can do it on your own, the rest of it. Okay, so here we go. Let's write down the given. All right, Jackson, help me out, buddy.
So number 2. Angle JMK is congruent to KML.
Hold up. JMK is congruent to angle what?
KML.
Perfect. Why is that?
Bisect theorem or definition of bisect.
Yeah, we'll just say definition of bisect. All right, so now we're going to mark it. Now they already said angle J is congruent to angle L. All right, so now what?
Theorem.
All right, I'll wait patiently.
Okay. KM is congruent to KM.
You are amazing. KM is congruent to KM. Why is that?
Reflexive property.
Right, reflexive property of equality. Okay, now I'm marking 3. Now what?
JM is congruent to LM.
Are the triangles congruent now?
Yeah.
Why?
Angle side angle.
Really? Look carefully. This,
Angle side.
right, is everybody, now again, everybody, people make that mistake, so I'm trying to correct it now. Is everybody seeing that is not angle side angle? That is what? Angle side. If you don't see it, that's okay. Just tell me though. Or I can't show you if you don't tell me.
How can you see that as angle side?
So watch me. Angle side. Right? It's not angle side angle because the side has to be between the two angles. Is the side between the two angles? Do you understand me now? Right? Angle side. All right. That for whatever reason is a little bit more difficult to see. But James, you're good now, right? All right. Anybody else need me to say that a little better? Everybody's okay with that? No, I'm just asking you on this right here. That's all. Do you understand this so far? Okay. So you said that triangle, say it again, Jackson, I didn't write it.
Triangle JMK.
JMK is congruent to
KML.
JMK is congruent to what?
Triangle KML.
No, no. J corresponds to what letter?
L.
L. Say it again. Triangle
LMK.
LMK. That is important. All right. Now, why is that again?
Angles. No, wait. angle side.
Very smart. Just be patient. Take your time. All right, so now that the triangles are congruent, what's true about all the parts?
They're congruent.
By what statement?
CP,
You are amazing. Thank you for remembering that. CPCTC. JM is congruent to LM. Beautiful. All right, why is that true? Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. That is why. Anybody? Okay, now, I know, actually, now I can answer your question.
Okay, could I also have done JKM is, or angle JKM is compared to angle LKM?
Why?
You give the definition of bisection.
What do you, it didn't bisect that side. Do you see what I'm saying? It only says it bisects the angle. If it said MK bisects JL, that would be true, but it is not. Is it true though? Is JK congruent to KL, guys? Yes. Is angle MKJ congruent to MKL? Yes, those are what? Corresponding parts of congruent triangles. They just ask for other parts. Everybody good with that? Okay, so I think I've done a good job. 14, 15 are easy, just algebra. Prove 17, 18, 19, 20, and the one before that. All right, what else? Did I skip one? Yeah, I did. Yeah, so finish up, guys. Try the proofs. All right, try the proofs. And again, if you're not understanding the proofs, we will be here first thing in the morning. Come see me in the morning and I'll help you go through it. All right. But again, use the information, any of the proofs. All right. Any of the 4 methods you're allowed to use to prove the triangles are congruent. All right. And again, you can see it differently. All right. Everyone doesn't have to have the same proof. All right. Anybody have any else? Anybody have any questions?
What if you do CTC stack formula?
Say it again.
CTC
C stands for what?
corresponding parts make congruent
Of,
congruent triangles.
are,
Congruent.
corresponding parts of congruent triangles are congruent. That is what CPCTC stands for. Corresponding parts of congruent triangles are congruent. All right, guys, great.